Find the coordinates of the center of dilation if coordinates of the original figure are -4, 14, -10, 16, -12, 10, -14, 12, and coordinates of its image are 2, 1, 3, 4, -1, 2, 4, 3. So as you can see, the original figure is already drawn, okay, and this is given by these extreme big numbers here. And the image is drawn right here. You can see that as well. So now, notice that in order to find the center of dilation, we will need to first find the scale factor of this dilation, right? Because we don't know what the scale factor is. It's not given to us. So we're going to have to calculate it by using a couple of tricks. So I'm going to show you how to find the scale factor and the coordinates of the dilation using the graphical way, and then we're going to confirm that it's the correct center of dilation using the formula of algebra. All right, so let's first understand what the scale factor is, because without the scale factor we won't be able to figure out the center of dilation. All right, the scale factor, how do we figure this out? The trick is to first understand that any dilation that you're going to have, regardless of whether the scale factor is negative, positive, less than 1, greater than 1, or absolute value less than 1 or greater than 1 absolute value, regardless of that, you always know that the corresponding sides will be parallel to each other. All right, so there will be parallelism between the corresponding sides. Notice that the longest side is this side, and so is this the longest side, right? And you know that it's parallel, right? You know it's parallel because you can judge from the slope of it that it's parallel, right? Because here you travel 4 units and 2 units up, so 4 to the right, 2 units up. Here you travel 8 units to the right and 4 units up, right? So it's proportional change, which means that it's the same slope, right? And same thing with the other sides. Notice that this is a diagonal, right? And it's diagonal because it goes 2 down, 2 to the right. Here it's diagonal going 1 down, 1 to the right, right? Again, proportional change, okay? But for the sake of understanding how to find the scale factor and also using it to find the center of dilation using the graph, let's use this pair of corresponding sides, right? So I'm going to label this as point A and this point B, and we're going to label this. Now keep in mind that you don't want to label this as A prime, because notice that this image is looking in different direction relative to the this original figure is looking in the different direction, in the opposite direction, in fact, as compared to the image, right? Because the sharp pointer here, the sharp end, the sharp vertex here, the sharpest angle is pointing in the opposite direction of this sharpest angle, right? So from that information, we know that the K, the scale factor, has to be less than 0, right? When the scale factor is negative, you will get your figures dilated in such a way that one will be pointed in the opposite direction of the other, right? They won't face the same direction when the K value is negative. All right, so now we know it's negative, but what exactly is the K value? We need to figure it out. If this is going to be AB, we know that this is going to be A prime and B prime, right? And again, why? Because we're talking about opposite directions, right? Because the K is less than 0, so it's going to be the opposite ends, right? This is not going to be B prime, but it's rather going to be A prime, and the bottom one will be the B prime, right? And again, because the scale factor is negative. So notice that we can use another pair of corresponding sides. We know that this is parallel. This is parallel to this, right? And again, because we have a consistent change, right? 2 down, 2 to the right. Here it's 1 down, 1 to the right, right? So it's proportional, right? So we know these two are parallel. Okay, so now that they're parallel, we can use the fact that we can use any components of this side, right? And you can actually see yourself that this takes 2 sub-diagonals, right? One in one box and then the second one here, and this only takes 1 box. So we know that the scale factor is actually -1/2, right? Because this is twice as long as this diagonal, right? This diagonal segment is twice as long as this diagonal segment, right? But since we're starting from the bigger one and making it into a smaller one, we have to divide this by 2. So that means the scale factor, K, is actually -1/2, right? We know it's negative, but now we figured it out that it's -1/2 because this makes this side twice as short. as it was before. All right, so now we know that the scale factor is -1/2. Also, the beautiful part about the scale factor is that the distance from the center of dilation, okay, to any corresponding set of vertices is going to be also using the scale factor. So the distance from the center of dilation to any of, let's say to this A prime, is going to be 1/2 the distance from the same center of dilation to the corresponding vertex of the original figure. Now that's beautiful. Why is that very important for us? It means that we can actually draw a horizontal line segment like this, okay, taking the furthest point A into the farthest point A prime, right? So that's going to be a horizontal line segment that we can draw. Notice that this horizontal line segment is the distance, horizontal distance, be careful, horizontal distance between A and A prime. All right, and we can use the fact that the scale factor is also relevant here. So what does that mean? That means that you have to count this line segment, okay, and see how long it is, and then just take 1/3, all right, take 1/3 of this distance to arrive at the horizontal location of the center of dilation, all right? So let's find this distance. This is 4 units from the y-axis, and also negative distance that will be measured absolute value-wise. That's going to be what? That's going to be 14 to the left. So 14 plus 4 is 18. Okay? So we're talking about taking 1/3 of the 18, right? So this thing is 18. So 1/3 of 18 is going to be precisely 6. So that means you just count 6 to the left from 4, and you're going to arrive here, right? So we're talking about this being the x-coordinate of the center of dilation. And again, why? Why is because, like I said, the distance from the center of dilation to A, all right, is twice the distance from the center of dilation to A prime. So that means this distance is 2 times, as you can see it is, than that, right? That's why we can think of it as 3/3 being in one line segment, and just divide it by 3 and take 1/3, which will be the distance, horizontal distance, okay, from the x-coordinate of A prime to the x-coordinate of the center of dilation, right? So we already know that the center of dilation, the x-coordinate, so we already know the x-coordinate is -2. Now let's find the y-coordinate. Now the y-coordinate is done in the similar manner. Again, we're going to use, not this time, we're not going to use the A and A prime. We're going to use the furthest vertical points, the furthest vertical vertices in the image and in the original figure and the image. So where is that? That's going to be the B prime against the B, right? So let's draw that line segment vertically. So we're going to draw it, let's say, from here to here, okay? So again, notice that that's the distance, a vertical distance from the B to the B prime. All right? And again, using the scale factor, we can apply the rule of dividing the total distance by 3 and then counting that third from this point until we get to the y-coordinate of the center of dilation point. All right, so let's count what the distance is. We know that this is 16, but there's one shorter here because we're starting from 1, so this is going to be 15. All right, so this distance is 15. Taking 1/3 of that is going to be precisely 5. So you're going to add 5 to the y-coordinate of 1 to get to the y-coordinate of the center of dilation. Right, so that's going to be what? 1, 2, 3, 4, 5. So there you go. So where does that point us? This gives us 6. Right, so here we got -2. And here we got 6. So that means the center of dilation is going to be bingo, this point right here. And that's what? -2, 6. All right, so now that we found it, beautiful. Let's verify this point that it is indeed correct by using the algebraic formula to find the center of dilation point. And you're going to see that it's going to match up. All right, so where's the formula? The formula is going to be this. So when we're looking at the original coordinate x, let's say, of the A, and we're trying to find the x prime. All right, the x coordinate of the image, so I'm going to label it x prime. So that's going to be what? That's going to be the formula k times x minus a plus a. So notice, and the y prime is going to be the y coordinate of the a prime vertex is going to be the same scale factor, y minus a, sorry, not minus a, but minus b this time, plus b. And what are the a and b? The a and b are exactly the x and y coordinates of the center of dilation point. All right, so that's that. All right, maybe I should use green here for the b so that you're not confused. Right, we need to solve for a and b here because we are just verifying, right? So we're not going to use the known a and b because we're verifying it algebraically how to find a and b using the x prime, y prime, k, and x and y, right? Because we know those from the graph available. All right, so now let's go ahead and substitute. So now x prime is going to be the x coordinate of the image A vertex x coordinate, right? So that's going to be what? That's going to be 4. Scale factor we know, it's going to be -1/2. X is going to be the x coordinate of the A vertex, the original vertex of the original image. So that's going to be -14 minus A plus A. All right, and this equation, y prime, is going to be 3, the y coordinate here. Same scale factor. The y coordinate of the A point is going to be 12, right? So 12 minus B plus B. Now let's solve for A and B. So first equation, we're going to have 4. This is positive. 14 over 2 is 7. This is positive A over 2, right? Because 2 negatives, right? Multiply, and then plus A. So what does that give us? That gives us, if you subtract 7, that's going to be -3. This thing is going to be 2 over 2 plus A over 2. That's 3A over 2. 3A over 2. Multiply both sides by 2. Or you can divide by 3, whichever you want. This is going to be -6. All right, so -6 equals 3A. So A dividing both sides by 3 is -2. Bingo, that's good news, right? The A is already verified. It's -2. Algebraically matches with the graph. All right, let's solve the second equation. So 12 over 2 is 6, so -6 plus, right, because 2 negatives, B over 2 plus B. All right, so that gives us what? If you add 6 on both sides, that's a 9. Again, 3b over 2. Multiplying both sides by 2, you get 18 is equal to 3b. Dividing both sides by 3, we get 6 is equal to b. Now look, let's match that. Does that match what we have? Yes, it does. As you can see, the b is 6 algebraically and graphically. Okay, so I hope you enjoyed this video, and I hope you understand how we found the scale factor by using the slope and parallelism, of course, and how we use the scale factor to determine the which part of the segment stop in order to get the x and y values of the center of dilation. Thank you so much for watching.